Hey, hi, I'm Ramya, embedded software engineer at Microsoft Technologies. Welcome to this demonstration of the obstacle detection system using TDCA with Cortex board. In this video, we will explore how the system effectively detects obstacles using the IR sensor and integrating both virtual simulation and physical devices for real-time monitoring and response. This project utilizes a cortex. So how we are using this cortex wisely with this TDCA. So let's see what is TDCA first. TDCA is Target Device Communication Interface, which serves as a framework that bridges a simulated ATAS with actual hardware like Cortex board. This enables a seamless communication between host and the target hardware, which is the Cortex board. So, this facilitating a real-time data exchange which enhances the system testing and overall performance. So, the host application sending a command via the serial communication and target monitor reply back with the necessary feedback using the serial communication. So, this mechanism is used in this TDCA. So, now let's see the overview of the project. This system enables obstacle detection through sensors connected to an embedded device such as Cortex. With the TDCA, developers can simulate, control, and monitor obstacle detection in real time using an ARTA simulation on a host machine. This communication allows for immediate response to detect obstacle such as activating alarms. So we connect a stimulated environment through TDCA to the real hardware, allowing us to monitor and control the system in real time. The goal is to create a system that detects obstacle and trigger actions such as activating a buzzer, providing an efficient solution for robotics and automation. So next, we're going to see the components. IR sensor. This sensor detects obstacles by emitting the infrared light and measuring the reflected signal. And then Cortex microcontroller. So this is the main target board we are using here. It processes the data received from the sensor and controls the outputs like motor and buzzer and receive motor. So this is the motor we are using here as a vehicle purpose. So just you consider the motor is a wheel of the vehicle. So and then buzzer. So buzzer is for used to provide alert when an obstacle is detected. So this is used to alarm the people. So now let's see how the TDC is applied here. Here, the O system runs the monitoring and control logic and sending command to the Cortex microcontroller. So this Cortex uses its HAL is hardware abstraction layer. So this is the one that is making the host command into a target understanding manner. So this Cortex using this HAL to process the sensor data and execute the commands. And then the feedback of the target, whether the obstacle is detected or not. So, like that type of feedback is detected by the sensor, and then it is sent back to the host through the TDCI. So developers can use this feedback to adjust threshold and control the output or debug the issues all in real time without needing to reprogram the microcontroller. So now let's see the workflow of the project. Here you can see the IR sensor emitting the infrared rays and detect the reflected signal when an obstacle is present. And if that obstacle is detected, then the cortex Then this Cortex microcontroller trigger the alert mechanism. So using this buzzer, we're going to do a alarming, and then TDCA sends the real time data about the detection status to the host, allowing the dynamic adjustments or monitoring. So we can use this project for navigation purpose, and we can use for collision avoidance, and for parking assistance. While driving, we can detect the obstacle detection, and then we can use for security system to monitor the restricted areas and trigger the alarms when strangers or intruders are detected. So these are the benefits while using this project. Now let's see the coding part. Okay, coming to the coding part, we must include this TDCA.h to use the TDCA API calls, and then from OS application start function. So this is like a main function. You should initialize TDCA init. So this is the one to make the serial communication between host and the target. So here you should use your COM port number, and then you make this initialization, and then you just use the following output and input APIs. So this is a TDCA APIs to define which pin and port is for input, and which pin and port for output. So this is must. You should define that so that according to the pins will work based on that, and then the following Cortex code for the project. So now I'm going to run this project. So you can see that command is setting from the host side, and then we are getting a response from the target both side. So each command is giving a success status based on executing the API one by one. So this is doing read the pin API, writing the pin, all the APIs it is sending command from host, and then we are getting a either success or failure status from the target hardware side. So now actually it is telling there is no obstacle, so that my motor is keep running. That's why A91. So one is running. So my motor pin is ninth pin from the A port. So my motor is keep on running because it is not detecting any obstacle. So when if I'm trying to detect the obstacle, then the sensor from 10th pin A port will detect the obstacle, and then my motor got stop, and then it will tell obstacle is detected. So that is you can see obstacle is detected, and then my motor gets stopped, and my sensor pin is detecting a param value 0. So this is how when the obstacle is detected, based on that my motor will run or off. So now let's see the hardware setup.
This is my hardware setup. I'm using a Cortex microcontroller board, IR sensor, buzzer, and DC motor. So consider this DC motor is the wheel of your vehicle. So whenever IR sensor detects any obstacle, then this DC motor immediately stops. So which mean the car immediately stops when it find the obstacle, and then buzzer will start alarming to alert the people. So now I gave all the required connection between the board and the components, and make sure you just restart your board before start your project. Okay, now I'm going to run this project. Okay, I started running this project. So initially it will set all the APIs, and then it will start running. So first it will check one by one the APIs, and you can see my motor is started running now, which means your vehicle is running now. So now there is no obstacle detected, so that my motor is not stopped working, and my buzzer also in off state. Okay, so this is the condition whenever normally a vehicle goes without any intrusion. So when I'm trying to detect the sensor, you can see my motor is stopped working and then my buzzer is started alarming. So now I'm not detecting the sensor, and then again my motor is started running, and then my buzzer also stops alarming. So this is the cycle it repeats whenever it detects any obstacle in front of the vehicle. So suddenly stop the vehicle and then alert the people by giving an alarm sound. So in the conclusion, this obstacle detection system demonstrates the power of combining the Cortex microcontroller with TDCI. This integration simplifies the development, speeds up the testing, and ensures a real-time interaction, making it ideal for automation and security application, even with robotics field. So thanks for watching.
So that's it. Thanks for tuning in. If you found this helpful, stay connected for more artist related videos. Bye.